Hello everyone. In this video, we'll be discussing about aliasing in digital images. Before getting into the actual concept, let's see let's see a small. What is a digital image? Digital image is a 2D function f of xy where x and y are its spatial coordinates, and the amplitude of f at any coordinate x comma y is called the intensity of the image at that particular point. We call the image as a digital image only when x, y, and the intensity values of f are all finite. The element of a digital image is called pixel. Sampling theorem in one dimension. The sampling frequency must be larger than or equal to twice of its higher frequency. By following this condition, we will be getting an oversample signal, violating which we will be seeing the condition of undersampled signal, which is the case of aliasing, in which distortion of signal takes place and loss of information happens. Similar to this, let's see sampling theorem in two dimensions. Sampling theorem in two dimensions is similar to sampling theorem in one dimension. Function f of t, whose Fourier transform is 0 for values of frequencies outside a finite interval, is called a band-limited function, where delta d and delta z are the separation between the samples along t and z axis. By following the above conditions, we'll be getting an oversampling sample signal, violating which we'll be observing the case of undersampling, where loss of information takes place. A continuous image f of t, which is band limited, can be converted into a digital form. For that, we have to sample the function in the both coordinates z and t in amplitude. This digitizing coordinate values is called sampling. Aliasing in images. If function is undersampled, then the phenomenon of aliasing occurs, which corrupts the image. The correction of image can be in the form of additional frequency components that are being introduced into the sample function, and these frequencies are called aliasing frequencies. Sampling rate in images is number of samples taken per unit distance. In the given example, the aliasing can be seen where the sample function looks like a sine wave with a lesser frequency than the continuous signal. In the image shown, we can see the example of sampling where the first image is shrunken to its size of its 50% by deleting the pixels that is shown in the second image, and the third image is observed where which is obtained by blurring the image one using 3 by 3 averaging filter. Anti-aliasing. Anti-aliasing is a method used to reduce alias diagonal edges in an image. It reduces through blending or smoothing by applying a low pass filter before downsampling the original image. Now let's see uh, how an aliased image looks through MATLAB implementation. Now let's see aliasing through MATLAB. I think you'll be having the basic idea of how to use MATLAB and how what is meant by a basic syntax in MATLAB. I'm going to explain the few inbuilt functions which are been used here. So the IM read basically reads an image or takes the input as an image from the device which we are using, and IM show displays the image, whereas IM resize is used to resize the image. It's basically used to shrink or enlarge an image. In the IM read syntax, we'll write the path of the file which we have used. That is, once you'll this path you can get it by you opening the properties of that particular image. So after resizing the image we have taken, I have resized it to 20, it to its 20%. So once I run the code, this is the image which we have taken. This is the original image, and after running the code, we'll be getting this aliased image where we can see clear distortion and aliasing of the edges happening. So this is aliasing in digital images.